it's going to say write this as a matrix equation. So first we need to write it at -6, -4, 3, just the coefficients, 12, -8, -8, 6, 2, -3, times xyz equals -14, -7, and 10. So then when I multiply it by the inverse matrix, and I'm going to save the 12th after I multiply it because it's easier to do. So I'm going to multiply my inverse by this one. But remember, when I multiply the inverse, I know I'm going to get this. Because A times the inverse is going to be the identity. Remember, A times the inverse is the identity matrix. So I'm not actually going to multiply this out because I know that it's going to be the identity times xyz. And then I put the inverse. We're going to save the 1/12 because I don't really want to do 20/12, 3/12. And so we're going to leave it like this. And then -6, 0, -6, 36, -6, and 48. That's my inverse, and I'm going to times it. See, I times the inverse on this side. I got to times it on this side too. So I get -14, -7, and 10. So then I take the first row and multiply it through here. And I get, forget your 1/12 out front, I get 21 when I multiplied 20 times -14 plus -3 times 7 plus 28 times 10. You can do that in your calculator. You get 28. So I'm done with that row. Then I take -6, 0, and -6 and multiply it through, and I get 14. And then I take the next row, 36, -6, and 48, and multiply it through, and I get 18. And on this side over here, remember the identity just gives me xyz. So now I have the answer for xyz, which is going to be 21/12, which reduces, if you do that in your calculator, you'll get 7/4. And then 14 over 12, that's not 14, that's 24. Didn't do that right, did I? -6 times -14 and is 24. So that gives me 2. And then 18/12, they both divide by 6, and I get 3/2. But you can do this on your calculator. So you can leave it like that, or just clearly so you can see the answer better. It's going to be like that. But your one on the test will be more like the exam that you did on our last exam, where you're not going to have a 1/12 out here, okay? Okay, so now this is the last one on question 9. Given a polynomial, these are my zeros. And so if I want to make a polynomial, I need factors. And remember, the factors are x minus the 0. So I'm going to do -1. So that's going to become +1. And then 2 plus I, well, it needs to be degree 3, but remember, I got to include 2 minus I. So I'm going to show you 2 different ways to do this, and you can decide which way you want to do it. First, I'm going to do this part, and then we'll come back to this one. So you can just distribute through the parentheses here, x minus 2, and then plus I. And then just distribute these. This is a trinomial, and so is this one. So we're just going to distribute. X times x is x squared. X times -2 is 2x. I'm just distributing the x through. And then plus xi. And then I'm going to distribute the -2 through, and I get -2x. I'm just going to line them up in like terms. -2 times -2 is 4. And then -2 times I is -2i. So we put that over here. Then I'm going to distribute the -i through, and I get -ix or -xi, put with that one. And then -i times -2 is +2i. And then negative I times negative I is minus I squared, which remember is negative 1. So these cancel and this cancels, and I'm left with x squared minus 4x, and then 4 plus 1 plus 5. And then I bring down the x plus 1 and distribute it through. So I do x cubed minus 4x squared plus 5x, and then x squared minus 4x plus 5. And so my final answer is x cubed minus 3x squared plus x plus 5. And then I want to check this and make sure it works. So I'm going to check this 0 of negative 1 and see if it works with this polynomial that I created. So I bring down the 1. It's negative 4. That's 4 and 5 is negative 5. Sure does. And look what it gives me. It gives me the polynomial that I multiplied my x plus 1 by. Okay, so now I'm going to show you another way to do this, and you can do it whichever way you want. Okay, so we're going to take and write these again as x plus 1, and then x minus 2 plus I, and x minus 2 minus I. Because remember, when I have a imaginary, I need its conjugate also. So I'm going to distribute through here again. I'm going to ignore this one again. X minus 2 minus I, and then x minus 2 plus I. Well, this time, instead of distributing everything through, I'm just going to add a set of parentheses here. Now look what I have. A minus b times a plus b. Because my x minus 2 is the same in both of them, and I have minus I and plus I. Well, remember, a minus b times a plus b is a squared minus b squared. So I can go like this, a squared minus b squared. My a is x minus 2, and my b is I. So x minus 2 times x minus 2 is x squared minus 4x plus 4. And then minus I squared is minus negative 1. So again, I get, this is x squared minus 4x plus 5 again. And then bring down the x plus 1. Multiply it through just like we did before. I get x cubed minus 4x squared plus 5x. And then with the 1, I get x squared minus 4x plus 5. And I get the same answer. This gives me minus 3x. This gives me plus x. I get the same answer either way I do it, so it does not matter which way you decide to do it. Okay? And that's the end of page 9.